Hello, mayang adlaw kaninyong tanan. Today, I will be discussing a new topic. So welcome to Engr.G channel. I will be discussing antiderivatives. So this is a topic next to derivatives. So going back to derivatives, if we have a function here, y equals x squared plus 7x minus 4, its derivative is y prime equals 2x plus 7, or we may also call that the derivative of y equals 2x plus 7. So, going back to the antiderivative, definition 1. Antiderivative is a function f is called an antiderivative of f on an interval I if f prime of x, that is a big letter F, equals f of x. So this is a small letter x for all x in the interval I. So we will tackle that. This one, f prime of x equals to f of x. Unsay pasabot ana niya. Notice the phrase an antiderivative, not the antiderivative. This is because there can be more than one antiderivative for the same function. So we will have an example. Why does the definition say that there are more than one antiderivative to one function? So here in example 1, we will discuss that for the function f of x equals 2x plus 7, find an antiderivative of f. Then, letter B, find another antiderivative of f. Then, C, find yet another antiderivative of f. So, what will be the answer? F of x. So, if you notice, that is a big letter F. F of x equals x squared plus 7x minus 4. And B, f of x equals x squared plus 7x minus 3. Letter C, f of x equals x squared plus 7x plus 428.72. So, these three here, these three equation can be an antiderivative to the equation f of x equals 2x plus 7. So, the definition says that the pag antiderivative f prime of x equals f of x. So, if ang derivative ani niya, here, f of x man siya, and then this one, ang definition is if the big letter if the first derivative of the function x equals to f of x, then that is its antiderivative. For example, we will look for the derivative of this. F prime of x of this letter A function equals 2x plus 7. Same here for the letter B. Its derivative is 2x plus 7. And for this letter C, its derivative is 2x plus 7. So, this f prime of x equals f of x, which is the given here. So, if this is satisfied, meaning these equations here, A, B, and C, are the antiderivative of this given f of x equals 2x plus 1. That's why it is said that there are more than one antiderivative to a function. Therefore, f of x equals x squared plus 7x plus c. So, c here is any constant. When we say constant, it can be any number or a natural number, integers, rational, or irrational. So, that's why there can be many antiderivative to a function because there can be many possible values of this constant. This one, this plus c. Okay, where c is a real number. So, when you say real number, natural number, integer, rational, irrational, or whole number. Next, definition 2. Most general antiderivative. The most general antiderivative of f is the collection of all possible antiderivatives. So, collection. So, unsay kalahian na niya sa definition 1. So, example 2. Find the most general antiderivative of this function. So, same given. Same function lang ang given to the example 1. So, f of x equals 2x plus 7. So, its most general antiderivative would be f of x equals x squared plus 7x plus c. So, when we say general, this part here and part is just plus c. It is not defined. It is not a defined number. When we say defined, it is not plus 3, plus 4, or plus pi, or any real number. So, if you will be asked, what is the most general antiderivative? So, the last part would be plus c, or plus constant. Number 3, find the most general antiderivative of f of x. Was cosine x. So the derivative of sine x equals cosine x. So please excuse these writings. So the derivative of sine x equals cosine x. So sine x here is the cosine x here is the f of x. And the antiderivative of this one is sine x plus c. So, plus c. There is a plus c. So, that is the most general antiderivative of cosine x. So, if you can observe, antiderivative is just the reverse of the derivative. So, if this is an f of x, this cosine here is the f prime of x. And if we will find the antiderivative of this prime of x, it would turn back to the f of x, which is this one. Next, indefinite integrals is another name for the most general antiderivative. Okay, suppose f is an antiderivative of f on the interval I. Then the indefinite integral of f on the interval I, written, the integral of f of x, or dx, or the integral of the function x dx is the most general antiderivative of f. So this is the equation. So the integral of f of x dx equals big letter f of x plus c, where c is a real number. Okay, so this equation here, or this notation, the integral of f of x dx, can be read as the integral of x with respect to x, or the integral of f of x dx. So this one here, the integral of f of x with respect to x, or the integral of f of x dx. So where the latter letters are pronounced by their names individually, but with a pause before the dx. So either way, whichever you will choose to read, it is just the same meaning. It has the same meaning. Example 4, evaluate a, the integral of 2x plus 7 dx, and the the integral of cosine x dx. Okay, the function inside the integral is called integrand. Okay, integrand. So, in this letter A, the integrand is this 2x plus 7. And the integrand for B, letter B is the cosine x. Okay, so to evaluate, so letter A, the integral of 2x plus 7 dx equals x squared plus 7x plus c. So that is based on the equation. So let's go back to the equation. So the equation is, we will write it here, f of x dx equals big letter f of x plus c. So the given here, this one, 2x plus 7, this is the f of x. And this one here is the big letter f of x. So, and this is the integral of 2x plus 7 dx. So, muna ni siya ang iyahang general antiderivative. Next, for the cosine x, so the integral of cosine x dx equals sine x plus c. So, sine x plus c is its most general antiderivative. Okay, note to remember. The derivative can be taken term by term. Number 2, constant multiples can be carried along to the derivative. Okay, illustration. The derivative of x raised to the power of 4 with respect to x equals 4x cubed. So, any derivative calculation can be reversed to give an antiderivative. So, as a review, the way to get this one, this is n x raised to the power of n minus 1. So, this is the power rule. Power rule of derivative. So, that is why it is 4x cubed. Bring n is 4, is 1, n is 4. So, we'll put the 4 here times x, and then 4 minus 1, that's why it is 3. So, this is the illustration. So, derivative of x raised to the power of 4 with respect to x equals 4x cubed. So, this 4x cubed here, this is the one that we will get the antiderivative from. So, the integral of 4x cubed dx equals x raised to the power of 4 plus c. So, why is it there is plus c here? Even if we all know that the given is just x raised to the power of 4. Why is it there is a plus c? So, remember that it is not all the time that you will know the origin of the given. So, there is a plus c to consider the constant that is with the original equation. So, constant, it can be a 0 or a 1 or a negative 1. So, positive, negative, or a 0 number. Okay. Antiderivative power rule. So, here is the first rule that we will be discussing. I will be discussing for any real number n not less than negative 1. So, this will be its rule. The integral of x raised to the power of n with respect to x equals x raised to the power of n plus 1 divided by n plus 1 and then plus c. So, there is always a plus c here for the answer. Example, evaluate the integral of x raised to the power of 6 dx, and b, x raised to the power of negative 3 with respect to x. So find its integral. Number 1. So the integral of x raised to the power of 6 dx equals x raised to the power of 7 divided by 7 plus c. So this is the answer. So if we will apply that rule, the power rule that says x raised to the power of n with respect to x equals x raised to the power of n plus 1 divided by n plus 1. So if we will look at here, n here is 6. So x, and then 6 plus 1, so that's why it is 7. And then divided by 6 plus 1. So x, 6 plus 1 divided by 6 plus 1. So that is why it become x raised to the power of 7 divided by 7 and then plus c. Next, the integral of x raised to the power of negative 3 dx equals x raised to the power of negative 2 over negative 2. So applying this rule or this equation, so the integral of x raised to the power of negative 3 dx would become x n plus 1 divided by n plus 1. But the n here is negative 3. So x raised to the power of negative 3 plus 1 divided by negative 3 plus 1. So that's why it become x raised to the power of negative 2 divided by negative 2. And then plus c. So this is the answer. Next, there is an exercise. So I hope you will answer this one just for a review. So next one is antiderivative constant multiple rule. So for any real number k, the integral of k times f of x with respect to x equals k times the integral of f of x dx, assuming the latter integral exists. So how will we apply this one? So antiderivative constant multiple rule. So multiple rule. So example, the integral of 11x raised to the power of 4 with respect to x. So here's the answer. 11, this is a constant. So it will not be included in the integral. So I will show you another solution to be clearer. So integral of 11 x raised to the power of 4 dx equals, so the rule said that you will put the 11 or the constant on the left side of the integral sign. So 11 times the integral of x raised to the power of 4 dx. So this part here, the integrand with the dx, will just be the integral part. So equals 11 times x raised to the power of 4 plus 1 divided by 4 plus 1. So this will become 11 x raised to the power of 5 divided by 5 and then plus c. So that's why this is the final answer. Next, another exercise, and I hope you do this also. Antiderivative sum rule. So the integral of f of x plus g of x. So there are two functions given, f of x and the g of x. So the integral of f of x plus g of x with respect to x equals the integral of f of x with respect to x plus the integral of g of x with respect to x. And then, similar to the difference rule, but with the subtraction sign, the integral of f of x minus g of x with respect to x equals the integral of the function x, f of x dx, minus the integral of the g of x dx. So, how will we apply this one? Example. So, letter A here is find the integral of, or the indefinite integral of the quantity x squared plus x raised to the power of 5 with respect to x. So, this will become to the given. So, x squared has a different integral sign, and then x raised to the power of 5 has a different integral sign. So, there are two integrand, the x squared and the x raised to the power of 5. So, the answer would be x raised to the power of 3 divided by 3 plus x raised to the power of 6 divided by 6 plus c. So, why does it become 3 here? So, n here is 2. So, x 2 plus 1 divided by 2 plus 1. That's why it become x raised to the power of 3 divided by 3. And this one, x raised to the power of 5, x raised to the power of 5 plus 1 divided by 5 plus 1. So that is why it become x raised to the power of 6 divided by 6. So this is the final answer. X raised to the power of 3 divided by 3 or over 3 plus x raised to the power of 6 over 6 plus c. Letter B. Okay. So, the integral of 4x raised to the power of 5 minus 2x cubed dx equals the integral of 4 times x raised to the power of 5 with respect to x minus the integral of 2 times x cubed with respect to x. So, similar here, 4 times x raised to the power of 6 divided by 6 minus 2 times x raised to the power of 4 divided by 4 plus c. So, if you are confused about this one, you can put here a bracket like this one. And then inside the bracket, you can put it here to be clearer. So, you cannot subtract the 2 here directly to the 4. So, it's not possible because it is in a different integral. So, you still need to simplify this one to get the final answer. So, the final answer here, so this is 4 and 6, 3 and then 2, and this one, 2 and then 1. So, that's why the final answer is 2 over 3 times x raised to the power of 6 minus 1/2 times x raised to the power of 4 plus c. Okay, another exercise. So, if you have any question about exercises, you may put down or write it in the comment section. Next, antiderivative of a constant. So, for any real number k, the integral of k with respect to x equals k of x plus c. So, when you say any real number, it can be a natural number, a rational number, irrational number, or it can be a 0. Example, evaluate the integral of 632 with respect to x. So, going back to the equation here, so it is said kx. So, kx. I'll put it here. The integral of k with respect to x equals kx plus c. So that is why the answer is the k here, 632. That is the k. This one. So kx, so with the x. So the final answer is 632x plus c. Another example. Calculate the integral of 2x raised to the power of 5 plus 9x raised to the power of 4 minus 1/5 x cubed plus 2x plus 11.5 with respect to x. Okay. So this one here is directly integrated. So it should be 2x raised to the power of 5 plus the integral of 9x raised to the power of 4 minus the integral of 1/5 x cubed plus the integral of 2x plus the integral of 11.5. Oh, I forgot the dx part. dx. So dx. There is a dx at the end of the integrand. Okay. So after that is this part. And then plus c. Okay, so after this one, if is this part. So 2 times x raised to the power of 6 over 6 plus 9 times x raised to the power of 5 over 5 minus 1/5 times x raised to the power of 4 divided by 4 plus 2 times x squared divided by 2 plus 11.5 x plus c. So simplifying that, so this would be the final answer. 1/3 x raised to the power of 6 plus 9/5 x raised to the power of 5 minus 1/10 times x raised to the power of 4 plus x squared plus 11.5x plus c. Another exercise. Okay, manipulating integrands. So how about this one? So here is a little complicated given because there is an x outside the quantity x squared minus 3x. So the integral of x times the quantity x squared minus 3x with respect to x. So before integrating this, you will need to simplify this part. So substitute x here. You multiply that x to x squared and to the negative 3x. So it becomes the integral of x cubed minus 3x squared dx. So after this, so the integral of x cubed dx minus 3x squared dx. So the answer is x raised to the power of 4 divided by 4 minus 3 times x raised to the power of x cubed over 3. So the 3 here can be cancelled. It will become 1. So the final answer is x raised to the power of 4 divided by 4 minus x cubed plus c. Another example. Evaluate the integral of x raised to the power of 5 minus 4x divided by 2x cubed with respect to x. So still you need to simplify here this integrand. This one. Simplify it first so that it will become easier to solve. So before this this become like this, it will be like this one, x raised to the power of 5 divided by 2x cubed minus 4x divided by 2x cubed dx. And then after this one is this part. The integral of 1/2 x squared minus 2x minus 2 dx. Okay. So 1/2 times x cubed divided by 3. So before this one is this part, the integral of 1/2 x squared dx minus the integral of 2x raised to the power of negative 2 dx. This one. And after this is this part. So 1/2 times x cubed divided by 3 minus 2 times x raised to the power of negative 1 divided by negative 1 plus c. So the final answer is, I will copy it because it is hidden by the writings, 1/6 x cubed plus 2x plus c. So why does x become the denominator? So this part here, you will multiply 2 to the 3, so it will become x cubed over 6. And then this part, negative times negative, so it will become positive. And then the power of the x here is negative 1, so it will go down to the denominator. That's why it become 2 over x plus c here. So similar lang na sila. Next, another example again. Evaluate the integral of 2x minus 1 squared with respect to x. So this one here is naka-squared, so we'll put here a bracket for you to identify easily the integrand. Okay, so simplifying that, it will become the integral of the quantity 4x squared minus 4x plus 1 dx. So before going here, it will become 4x squared dx minus the integral of 4x dx plus the integral of dx. So that's why it become 4 times x cubed divided by 3 minus 4 times x squared over 2 plus 1 times x plus c. So this will be the final answer. Equals 4 over 3x cubed minus 2x squared plus x plus c. The rules rule. Knowing what rules do not exist is just as important as knowing which rules do exist for calculating antiderivatives. So you must know what rule would you use in integrating. So here are trigonometric antiderivatives, a few trigonometric identity antiderivatives. So I will make another video for this one. So if you have questions regarding those rules that I've discussed, you can put it on the comment section below. So please do like and subscribe this video. Thank you.